So I'm going to say 77, we love it. It makes sense. Plus 36 multiplied by 1 minute plus 18, or we can keep it like 18 seconds. So let's worry about this much. Instead of 36 minutes, I put 36 times 1. Question here, why did I do that? So that's a cheating way to make it to a degree. 36 right now doesn't have any units. 1 minute. In your note sheet, we have 1 degree equal to 60 minutes. Looks like there's a traffic there. People are joining late. There is a traffic actually. So 1 degree equal to 60 minutes. 1 minute will be 1 over 60 degree. So instead of 1 minute, I'm going to put 1 over 60. And this, the unit is degree. So we have 77 degree plus 36 times 1 over 60 gives us 0.6. Is it 6 times 6? 6 over, give us 6 over 10, which is 0.6. Does that make sense?
Yeah.
So this is a cheating note that we do. So now 77 degree plus 0.6 degree, both of them, they have the same degrees. So I can write 77.6 degree. And we can use a calculator to add them. 77 plus 0.6 is 77.6 degree plus 18 second. Now we have problem with 18 second. How do I make this one to degree? I will write this as 18 multiplied by 1 second. So how big is 1 second? 1 second is 1 over 3,600 degree. So if I plug it back, we're gonna get 77.6 plus 18 multiplied by 1 over 3,600 degrees. What is 18 times 1 over 3,600? If you use the calculator, what do we get here, Elizabeth? Do you have a calculator handy?
Let me get it.
Or somebody else, if you can.
0.005.
0.005. Like this. Okay. So now we have 77.6 degrees plus 0.005. If we add them, we should get 77.605. So this will be degrees. Usually it tells you how many decimal to go. Any question? Mario, question? Check is gone. Vanessa, are you there?
Yeah.
So that's how we convert to so now number 19 is a backward. We have the decimal, right?
Professor,
Yes, no.
before we move, I have a question. So when we move seconds to degree, it's we divide it by 3,600.
Yes, if you have
What
a
about? Oh, sorry. What about
good-
minutes?
yeah, one so 1 minute is 1/60 degree,
Oh,
and 1 second will be 1/3600.
got it. Thank you.
I mean, those are perfect note on your note sheet. I mean, if you have it, you just plug it in and you're done. All right, number 19. So we're gonna do exactly backward. 63.41, it makes sense to some system in computer. Some system, they can just plot this or find 63.41, but some other system, they might only understand degree, minute, and second. All right, so we know why we're doing this, because some computer doesn't understand the decimal. So also there might be in the calculator, some calculator that you give them this, they give you DMS. But we are learning how the calculator works, okay? So we're gonna make this one to DMS. We have 63.41 degree. Again, we are doing little bit of algebra cheating. Cheating means we're not doing any mistake. We're just applying some trick. So 63 plus 0.41. So this is degree, that's degree. Correct? So 63.41 will be 63 plus 0.41. So this equal to 63 degrees plus 0.41 multiplied by 1 degree. This 1 degree, we have it right there. 1 degree is 60 minutes. So what I'm going to do, instead of 1 degree here, I can plug 60 minutes. So 0.41 multiplied by 60 minutes. What is 0.41 times 60?
24.6.
24.6 times this. So what the unit will be, this will be unit minutes, correct? So far we have 63 degrees plus 24.6 minutes. So the purpose of creating DMS is that all of them should be whole number. We cannot have decimal. So 63 is a whole number. We love it. We have 24.6. So we do the same style here. I'm gonna move this one. I'm gonna write it here. Okay. So we have 63 degrees plus 24.6 minutes. This is same as 63 degree plus 24 minutes plus 0.6 minutes. So instead of 24.6, I put 24 plus 0.6. So now this is a whole number, this is a whole number. Both of them are lovely, we understand it. What about 0.6 minute? 0.6 minutes, I'm gonna write 0.6 multiplied by 1 minute. So I'm gonna continue this part. Instead of 1 minute, 0.6 multiplied by 60 seconds, because 1 minute equal to 60 seconds. 0.6 times 60, it will be 36 seconds. Good. So now we love this as well. I move this over here. So the final answer will be 63 degree plus 24 minutes plus 36 seconds. But we add plus. I'm going to remove the plus because we don't need to add plus here. We cannot add them. I mean, if you leave it, is okay, but without it is much better. So this will be the answer. All right, Elizabeth, you good?
Yeah.
Whew. Any other homework question? I posted.
I have one more if you want to do it.
Sure, if it's not same, I will be happy to do it.
It's kind of the same.
So what is it?
It's 100.
Did you try to solve it?
Yeah.
Okay.
It's because there's a lot of steps that I keep getting it wrong because I like keep missing like one step each time.
So that's good that you know you're missing one step each time. So you should not have those mistakes on the exam or quiz. But okay, tell me what is that?
It's convert angles to degrees again, 136.34 degrees.
To DMS?
Yeah.
So I know you said there are a long way to do it, but the point is you know how to do it, correct? We know when we're going from degrees to DMS, so there are two things we should do. Minutes, 1 degree is 60 minutes and 1 minute equal to 60 seconds. That's what we're gonna apply. But if we go the other way, if we go from DMS to decimal, to like decimal, we do 1 minute equal to 1/60 degree and 1 second equal to 1/3600 degrees, correct? So now we clarify something. So you don't use this, you don't even look at this if the question is this way. Right? So the first thing, the decimal here, we're gonna have 136 degree plus 0.34 degrees, correct? We do cheating here, 0.34. I'm gonna write 0.34 multiply by 1 degree. Instead of 1 degree, I'm gonna use this one. We're gonna have 0.34 multiplied by 60 minutes. So this degree convert to minutes. Now you use your calculator to get this.
20.4.
24, 20?
20.4.
20.4. What's the unit of this?
Minutes.
Very nice. This is minute. Everything is minutes. Now, this is same as 20 minutes plus 0.4 minutes. So I disjoin this one, same as I did at the top. 20 minutes, we love it because it's a whole number. We love 136 as well. But 0.4 is bothering us because it's decimal. So 0.4 minute, this is same as 0.4 multiplied by 1 minute. Now instead of 1 minute, I'm going to put 60 seconds. This is 0.4 multiplied by 60 seconds. It will be 24 seconds. So we have second, we have minutes. So final answer will be 136, 20, 24. You shouldn't forget the units.
Thank you,
But
Professor.
what you said that was great, that you know there are so many steps. If you know if you do one mistake in one steps, then the result will be wrong, correct? For sure, it would be different angle. So I know that I do it most of the times. I make sure to have a bigger font, use colors, and to review it before I submit it to the homework. And that's a perfect practice. And after a few examples that you do it correctly, then you will get a good confidence. All right, any other question? Any questions regarding quiz?
So we can use notes.
Yeah, I mean, I cannot see what you're using, yeah. As long as it's you, I'm okay. This is a quiz. For the exam, you're welcome to use notes and book as well. But the exam, I will see you guys while you're taking the exam. And usually it's not a good time to go through your notes. It would be good to have a couple pages of notes ready to take the exam. You don't want a pile of notes to go through it. It should be organized. Any other question?
I can't seem to find it on my Pearson.
It will pop up at 10.
Oh, okay.
It's hiding. So you guys know, if you click it, you have to finish it. Don't click and take a picture or just view it. So I'm going to take it after dinner tonight. No. If you click it, you should finish it. I know I will get some people that they ask me to reopen it, but I'm not going to reopen it. So back to our circle, our beautiful circle that you will see it so many times in this course. So this is a circle. I'm going to call it unit circle. Unit circle is a circle that has a radius 1. So r equal to 1. That means from here to there is 1. And the center h and k are 0, 0. Go. We go counterclockwise to make some degrees. For example, I'm going to go to 45 degrees. So this angle is 45 degrees. I'm going to call this alpha. Alpha is 45 degrees. What is a coterminal angle for this?
45 degrees.
What's that? Say again.
45 degrees.
Yeah, 45 degrees. The coterminal is an angle that the initial side and this side, the terminal side are same. It will be 360 plus 45, 405. It would be 405 degrees. The coterminal, again, that's it. I mean, 45 is like this. We said this is the initial side, that's a terminal side. This is alpha. Now, if I go 360 and back to this, I will end up having a same terminal side, correct? As long as my terminal side is same, then it will be co-terminal. It will be co-terminal. So it will be 4 or 5. And we can have as many one you want as long as you stop here. Cool. I need to get rid of those things. I don't know what are here. So you see X and Y, correct? This is X, that's Y. Can you guys tell me what is the coordinate of this point? Jason, what is the coordinate of that point? Coordinate means if it's X comma Y, what is the value of X? What's the value of Y?
1, 0.
Excellent. X is 1, Y is 0. How does he know? Because he didn't sleep last night. No.
I do have a baby right here.
So this, I know is in the circle, but there's an X here, correct? And we know this much is 1. So X is 1 and Y is 0. Elizabeth, what point is this? What's the coordinate of that point?
0, 1.
You mean 1, 0, 1, yeah.
Yeah.
I was doing a mistake. What about this point? Mario, you're so fresh for this. What point is this?
The black one?
Yeah.
Oh, that's -1 and 0.
And I do this one. This is 0, -1. All right. So to make this story short, by the end of this course, you're gonna find all the most of the coordinate on the circle. I mean the coordinates around here. That's what is trigonometry. That's what we're gonna learn. So we start with the easy one, 1 and 0, correct? So good, you guys are following me. I mean, I just picked a few people, but so this is 0. This is 90 degrees. This is 180 degrees. This is 270 degrees and 360 degrees. Correct? If I ask you guys in radiant, you're able to tell me radiant as well, but I want to keep the radiant a little far away for now. Let's understand this. For example, I asked Mario, what point is this? He said -1 and 0. I could ask, what is the coordinate if alpha is 180 degree? If this alpha is 180, correct? 180, the coordinate is this. Good. What is coordinate of X? What is the coordinate of X when alpha equal to 270 degrees? X will be 0, correct? So now you will learn about sine and cosine. This X here is cosine of alpha. So we are defining it. Don't freak out. I mean, when I say it, you will learn X equal to cosine of alpha. What is Y? Y will be sine of alpha. We are defining it. There is no proof for it. So now, one Bitcoin question. You guys don't believe me, correct? I can just say Bitcoin, don't ask me, don't email me, so where's my Bitcoin? But I'm just saying that's the price. What is sine of 90 degree?
One.
Excellent, is 1. So what is sine? This sine, that means we are looking for y, correct? And there's millions of y here. Which y? The y that alpha is 90 degrees. Alpha is 90 degrees is here. Good. So alpha is 90 degrees is here. So we are dealing with this coordinate. Sine is related to y. So sine of 90 is 1. What is cosine of 270 degrees, Elizabeth? Let's challenge you, that you challenged me early morning. What is cosine of 270? Look at this 270, correct? You need to visualize this. 270 is right here. This is 270. From here all the way here is 270. The circle cross the y-axis at this point. So 0 and -1. So 0 and -1 is x comma y at 270. Now you just learned x is cosine and y is sine. Because we are in that point, so it's cosine of 270 comma sine of 270. So what is cosine of 270 is 0. Sine of 270 is -1. So the answer is 0. The unit circle that you said last time, Elizabeth, is this one. So we are only find 4 so far. The unit circle, if you Google it, it gives you all the coordinate of the circle. It gives you all the x and y around there. And that's what we going to learn and use a unit circle for this course. So it's not that bad. Don't freak out. Any question regarding this? No? So let's make it a spicy question. Spicy means it's okay. Sine of 180 degrees plus cosine of 90 divided by 5 cosine of 360. Do you see how we make it kind of doesn't look good to you guys? What are you doing in your head? Are you solving in your head?
No, I was just saying yes, that you said that you make it complicated.
No, I don't make it. You guys think I make it complicated. To me, it's
Oh.
not complicated.
Yeah. That's what I'm saying.
I want you guys don't have that fear. There's nothing to scare of. So there is a question like this. If I ask you this question like last week, you would think, oh, this is super, super complicated. You need at least a couple Bitcoins to solve this one. But now we are dealing with sine and cosine. In your note sheets, you said x is cosine of alpha and y is sine of alpha. You cannot say x is cosine, y is sine. No, x is cosine of alpha. So x is the value of, for example, this. When you make that much angle, this makes x and y. So x will be cosine of that angle. So what is sine of 180?
0.
Okay, this is gone, 0. What is cosine of 90?
0.
Great, K1, I just made the question. 0. What is 0 plus 0?
100. I'm joking, 0.
Yeah, that's good to start the week with the 0 plus 0 is 100. 0 over 5, cosine of 360 is 1, correct? 0 over 5 is 0 over a number, the answer is 0. Are we good? So do not freak out of type of question. Just dive in to see what do we have. All right, so now that you know, let's see if somebody in the waiting room that emailed me record. Now my question is, what is cosine of 45 degrees? All of the sine and cosine or tangent, cotangent you're going to learn, we can use a calculator. So your calculator will pass, I mean, you're going to get the correct answer with the calculator. But the problem is I'm not, for example, can you use the calculator? Any of you guys tell me what is cosine of 45? Elizabeth, what's that?
0.7.
Say again.
0.7.
0.7. Yeah, that's correct. But this is exactly 0.7?
No, it has a lot of decimals.
I know a lot of this, but tell me a few of them. Few of this.
0, 7, 1, 0, 6, 7, 8, 1.
You see, this is, thanks, Mario, but this is ugly. We don't want this. They said find the exact. Exact mean we don't want, I mean, this is Mario calculator went to 1, 2, 3, 4, 5, 6, 7 decimal. But if this doesn't have an end, it goes to infinity. I mean, there is no pattern. If you have a big computer and print it, the digit gonna go to 100 pages. All right. So what's gonna happen if they ask us what is cosine of 45 in exact value? So first we're gonna visualize it. This is 45 degree. Agree, Mario? This is very interesting. Just follow me how I'm solving it. And this is create x and y. Cool. X is cosine of 45 and y is sine of 45. Basically, they're asking us what is the value of x, which is exactly cosine of 45. Good. Cosine of 45 is scary, but if I ask you what is the x value here, that's what we're going to solve. Any of you guys have any idea how should we get that x? Is Yvette there?
Yeah, no idea.
No idea. Good. Edison?
Oh.
So here's the beauty of trigonometry.
Oh, wait, I think I know the decimal conversion with the minute.
Oh, no, 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 good idea. No, thanks for sharing it. No, we are, so this is a degree, correct? Cosine of 45. We get something that is a distance. I mean, 0.71 is like a whatever is the unit of x, if it's inches or centimeter, but this don't go there. I'm gonna make a right triangle here. So now in this right triangle, this is 90 degree, correct? So again, this is the triangle we are dealing with. That's much prettier. Let's do it this way. All right. Can I call this much X and this is Y? Mario? Yeah. This point has X, correct? And Y. X is here and Y is there. Elizabeth, yeah, no. Yeah. For example, there's a point here. I'm just gonna say this point is like a negative 0.8 comma 0.2. That means this is 0.2 and this much is negative 0.8. Good, that's according to X and Y. Now you see it on the circle, but forget about circle. This point has X and Y, and that's how we find it. So if we solve for X here, then we solve for cosine of 45. We have a right triangle. I'm going to make it here. This is 90 degree. This is X we are looking for. That's Y. What else do we know? We know this is 45. If this angle is 45, what is the measure of this angle? Jake, what is the angle of this?
45.
Yeah. So this is 45 as well. What else do we know? So we are trying to solve the triangle. We're trying to solve this X. What else do we know about this triangle?
It's a 90 degree.
90 degree, very good. What else? Do we know any measure of this? Do we know the hypotenuse?
That's 1.
Yeah, this is 1. So we know one thing, 1. We also learned different type of triangles on the week ago. If these two angles are same, we learn isosceles triangle, correct? Isosceles, these two sides are same, then the angle front of them are equal. So if this angle equal to that angle, the side front of it should be equal to that side. So here, X and Y gonna be same length. They're same, exactly same length. Good. So I'm gonna apply Pythagorean theorem. I'm gonna say X squared plus Y squared equal to 1 squared. Only Pythagorean happens on 90 degrees. X squared, instead of Y, I'm gonna put X because X and Y are equal. Good. X equal to Y because this triangle is isosceles triangle, or they call it 45-45. Who can solve for X here? I'm gonna ask Jake. Okay, you work it up. X squared plus X squared equal to 1. What is X?
Oh, I don't know actually.
Okay. Can I add them? Can I say there are 2x squared equal to 1? Good. X squared plus x 2x squared. We are looking for this X. We are looking for this X. I need to get rid of this 2 and then that 2. Good. Or this 2. So I'm going to divide by 2 both sides. Then we get x squared equal to 1/2. Now how do you solve for x?
Square root.
Very good. X will be plus minus square root of 1/2. If you use your calculator square root of 1/2, you should get something like this that Mario got. But we want exact. So how do we calculate this? This is same as plus minus the square root of 1 over square root of 2. This is same as plus minus 1 over root 2.
It's actually the same number. Oh,
Yeah.
here. Yeah.
Yeah. There is no magic in them. So should I leave it 1 over radical 2, or we are able to simplify it? Can we have radical on the denominator? In algebra, we learned that having a radical on denominator is not allowed. So so we have 1 over root 2. We learn to irrationalize it. So this is algebra, nothing to do with what we're doing. So I'm going to multiply by this radical 2, radical 2. I get radical 2 over radical 4 equal to radical 2 over 2. So what we got y equal to radical 2 over 2 and x equal to radical 2 over 2. There's a plus and minus there. Now it's your job to tell me, is this and this coordinate, this x and y, are the plus or minus?
Plus.
Both of them are plus, right? So the coordinate x and y will be radical 2 over 2, comma radical 2 over 2. So what is cosine of 45? Radical 2 over 2. In exam, if I ask you guys what is sine of 45, what do we say?
Radical 2 over 2.
Over 2. You're not going to use a calculator. And you don't need to go through this all algebra. This was a proof. So from now on, everybody in this session, they know sine of 45, cosine of 45. The answer is root 2 over 2 and root 2 over 2. And if you go to unit circle, you will see is root 2 over 2, root 2 over 2. Let me see if I can find. Oh. The loading use was here. When exactly on my x and y. Look at this is what Elizabeth was referring to. All of you guys should have this. Where is 45? 45 degrees right there. This is 45. I mean, this much is 45 degrees. Radical 2 over 2, radical 2 over 2. This is cosine of 45, comma sine of 45. If I give you this unit circle, can you guys tell me what is sine of 240 degrees?
Negative square root 3 over 2.
Very nice. Excellent. So you guys got it that sine represent the y. 240 is right there. This is a y. Is this. Good, Jason? Yeah. You're holding it. Good. Very good. Very good. And so that's 45. We learned about 45. So now is a tricky one. Let me go over a couple. So this is 45. Everybody, we know that this is radical 2 over 2 comma radical 2 over 2. This angle here how big is this measure? This is, I tell you guys, this is 180 plus 45, 225. This is 225 degrees. Good from here to there. This much was 180 plus 45 degrees. So this angle here is 45 degrees. If we make a triangle and apply the Pythagorean theorem, whatever we did, you will get the same distance, radical 2 over 2, radical 2 over 2, comma radical 2 over 2. But in this quadrant, both of them are negative. So you learn another angle, 225. 225, look, so this much is 225. You guys learned about coterminal angle, correct? There's another form, they call it reference angle. The reference angle is 45 degrees. The reference angle of 225 is same as 45. Because we need to make a triangle to find x and y. If you want to find x and y, we have to make a right triangle. So we always refer it to the first quadrant. Let's have, okay. So this one you learn. So this was 225 degrees. We had negative radical 2 over 2 and negative radical 2 over 2. We had radical 2 over 2, comma radical 2 over 2. What about this angle? This is 145, 135. 135 degrees. What's the reference angle? Reference angle always happens to the x-axis. This is a reference angle. If this much is 135, everything is 180, so this should be 45 degrees. So again, we're dealing with 45. So this coordinate will be negative radical 2 over 2. X is negative, but y is positive. And same thing here, I will go over it on Wednesday. This will be 315, 40, right? 315 degrees, same as 45. We get radical 2 over 2, comma negative radical 2 over 2. So with 145 degree, we find 3 more coordinates.